Hey, welcome back to your favorite Math 116 technical math class. We're going to take a look at the right triangle today, and there's a lot of application problems in science and technology that use this Pythagorean theorem and other characteristics of the right triangle. And in trig, we develop methods for measuring the sides of angles of triangles and their applications. And this right triangle is associated with the most famous theorem in all mathematics, the Pythagorean theorem, which says the sum of the legs of the triangle, so a squared plus b squared, is equivalent to the hypotenuse, which is the hypotenuse is the side opposite the 90-degree angle, right? Equals c squared. And this is just a little display of that. For example, if you have the side lengths 4 and 3 of the legs, right? So 4 squared plus 3 squared would equal 5 squared, right? 16 plus 9 equals 25. You can see the 4 squared is displayed right here in red, right? You got 16 of those squares, and then you add up 9 more of those squares, right? And you equal the green c squared, right? So 4 squared plus 3 squared equals c squared there. Let's go ahead and use the Pythagorean theorem. Here's our legs here, I'll call this one A, I'll call this one B, and that C is our hypotenuse is X. And so we go ahead and plug that in. A squared plus B squared equals C squared. So we got 6 squared plus 8 squared equals our X squared. Of course, 6 times 6 gives us 36. We got 64. So we got 100 equaling x squared equaling 100. And then we want to just make sure we undo the square by square rooting. Now, technically speaking, I square root both sides. I should have plus or minus 10, but this is a side length. So we're going to name the hypotenuse a side length of just the positive 10 there. All right, here we've got another right triangle, and notice they don't draw this for us, so we're going to have to label it angles A, B, and C. Opposite angle C is our hypotenuse. Opposite angle A is our leg, side length A, and opposite angle B would be our other side length B. So go ahead and write A. They give us A is 20, and they give us a hypotenuse 29. And so we've got A squared plus B squared equals 29 squared. So we got 20 is being squared, B we don't know, equals 29 squared. So we got 400, we got 29 times 29 gives us 841. We'll go ahead and solve for B squared. So we'll isolate the B squared. And now we go ahead and we square root both sides here. And we get B end up being 21. Because 21 times 21 is 441. So we've got a leg length here of 5. We've got a hypotenuse 9. Subtract 25 on both sides. You get B squared equals 56. And you square root both sides. And that's where you get the 7.48. And this is in meters. All right, we'll get into trigonometry now. Now, you can approach trigonometry either with a unit circle approach or a right triangle approach. We're going to do that with a right triangle approach, and just kind of a little bit of an introduction to trigonometry in this course. So we're going to look at the 6 trigonometric ratios, okay, of a right triangle. So the trig ratios are defined as the sine of an angle. We're going to call this angle theta right here. You see theta. So theta's opposite side would be right there. You see how that's the opposite side? The adjacent, meaning next to, the adjacent one is the leg next to it, would be right there. And then finally, of course, the hypotenuse is always opposite the 90-degree angle, right? So it depends on the placement of theta. You know, if we put theta instead, if we put theta up here, now the opposite side would be right here. Hypotenuse is still opposite the 90-degree, but the adjacent side would be right there, right? So it depends on the location of the theta angle, okay? Now, the 6 trig ratios say the sine of theta is the opposite side over the hypotenuse. It's that ratio. You know, if the opposite is 3 and then the hypotenuse is 5, the sine of theta would be 3/5, 3 over 5. The cosine of theta is the adjacent side over the hypotenuse. So if the adjacent side was 4 and the hypotenuse is 5, the cosine of theta would be 4/5, and so on. The tangent of theta here would be 3 over 4 for the opposite over the adjacent. And then the sine is the reciprocal of the cosecant. So the cosecant just flips over the sine. So instead of opposite over hypotenuse, it's hypotenuse over opposite. So instead of 3/5, right, opposite over hypotenuse, this would be 5/3. The cosine is the reciprocal of the secant. So instead of 4/5, it'd be hypotenuse over adjacent. And finally, the cotangent would flip over the tangent. Instead of 3 over 4, it'd be 4 over 3, the adjacent side over the opposite side. Right? And that's your 6 trig ratios combined. Now, when I was in school, I learned sine, cosine, tangent as with the acronym, oh, heck, another hour of algebra. But most people seem to learn it with SOHCAHTOA. Right? So I'm not sure which way you guys learned it, but you can remember either way from the 1920s or for SOHCAHTOA nowadays. Just kidding. I didn't learn that in the 20s, but I am old. Let's find the trig ratios here for the sine, cosine, tangent in both the exact form for both angle A and angle B. So if we do it for angle A, right now, let me highlight A. Whoops. Let me highlight A right here. Maybe it won't let me. So I highlighted angle A there. I underlined it. So the opposite side would be right here. Of course, we know the hypotenuse is always opposite the 90. And then the adjacent or next to side would be right there next to it, right? For angle A. Now, we don't know the adjacent side. So we're going to have to first, number one, let's solve for the side length. So we got A squared plus B squared equals C squared. A is 3. B is the adjacent side. C's at 6. We got 9 plus B squared equals 36 here. We're going to subtract 9. So we get B squared equals that's 27. We'll square root both sides. So B equals plus or minus, of course, is the positive 1. Now let me break up 27. 27 is 9 times 3. I know the square root of 9 is 3. And there's a 3 left over. Okay, so this adjacent side is 3 root 3, right? And now we're going to do the sine of A, the cosine of A, and the tangent of A. Oh, heck, another hour of algebra. Or SOHCAHTOA, however you want to remember that. So the sine of angle A would be the opposite side, so 3 over the hypotenuse, 6. Which of course reduces to 1/2. So we have the sine of angle A as a half. Cosine of A would be the adjacent over hypotenuse. So 3 root 3 over 6. And remember, 3/6 is 1/2, right? So I got 1 root 3, which is just root 3 over 2. Tangent of angle A is the opposite over the adjacent. Now 3 over 3 is just 1. So I got 1 over 1 times root 3. So I got 1 over root 3. I really should rationalize that. We can't have an irrational in the denominator. So I'm going to multiply it by top and bottom by square root of 3. And then I'll get root 3 over root 3 times root 3 is root 9, which of course is just 3. All right? And you could punch those in if you want a decimal form for those. All right? Now, what if we do it for, because it asks us to do the 3 trig ratios for angle B as well. All right? So for angle B, let's do that over here. Sine of angle B, cosine angle B, tangent angle B. Now, if I'm looking at B, right now I'm looking up here at B, all right, this angle right there, angle B. The opposite side would be who? 3 root 3, right? Hopefully you note that's now my opposite side. Hypotenuse is still the same hypotenuse. The adjacent leg or the leg next to it would be right there. So, oh heck, another hour of algebra. Sine of B is opposite over hypotenuse, so 3 root 3 over 6. And 3/6 is 1/2, so root 3 over 2. Cosine of B is adjacent over hypotenuse, so that would be 3/6 here, or 1/2. And finally, tangent's opposite over adjacent, so 3 root 3 over 3, which is just root 3. We'll note here on evaluating trig ratios given angles using a scientific calculator, you guys. We're going to use a calculator to do this. In calculus, you do find these, or you can find these by hand, and then they're just used to program your calculators that we benefit from. But I want you to note that your calculators can evaluate these angles in degree or radian. We're only going to be doing this with degrees. You notice the little degree sign right there, sine of 11 degrees, right? So make sure you're in degree mode on your calculator, and then you just pull up, let's go ahead and pull it up, our Desmos.com, our scientific calculator, and punch in sine of 11 degrees. See that degree right there? I want to make sure I click on that, make sure that's highlighted, and then you can click on function, you find the sign there. We're punching in sine of 11 degrees, and we get that 0.1908, blah, 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 blah. We can go ahead and punch that in, or enter our answer right here. So sine of 11 is 0.1908089954. We're going to round it to 4 decimal places. So I look to the right of the 8, it's a 0. Since it's not 5 or above, it just stays the same, 0.1908. Call it good right there. With the cosine, we'll go ahead and punch in the cosine of 31. Similarly, make sure your degrees, click on functions, see the cosine right there, 31 degrees. You get that 0.857167. 307. We'll also round this to 4. So we got 0.8577. And finally, let's punch in tangent 56. Similarly, make sure you're in degrees, 1.4. This is what you'd get here, 1.482560969. We'll also round that to 4. Okay. Now, we're also going to find angle measures when the values of the trig ratios are given. So we're going to have to use what's referred to as the inverse of the sine, cosine, tangent. So this is the inverse of the sine. That's also referred to as the arc sine. That's arc sine. This is the arc cosine. This is the arc tangent. again, or you can say the inverse of the tangent, or the inverse of the cosine, or the inverse of the sine, okay? So they will undo each of those respectively. Let me give you an example here. So let's look at this first one. Given that sine of A equals 0.86, so the sine of A equals 0.86, right? So we know the ratio of the opposite over the hypotenuse is 0.86, right? Whatever fraction that is that gave us that, right? 43/50ths or whatever. But so what would angle A be? What would angle A be? Well, we need to solve for A. So what we want to do is we want to undo the sine. And the way you undo the sine is you use its inverse. And so we're going to go ahead and find on our calculator the arc sine. And we're going to run it on both sides here, the arc sine. So on the left-hand side, we have the arc sine of the sine of A is just angle A, right? That just undoes it. And you can put a little angle on there if you want. Angle A. So it undoes it right there. So now I just got to punch this in to my calculator. Make sure you're in degrees when you do this. So I pull up my Desmos again. I go to my functions again, right? If I'm on the home screen, I go to my functions. And I punch in the arc sine of 0.86. Again, make sure you're in degrees right there. I am in degrees. And that's my angle, 59.316,582.89 degrees. That's my angle A. Degrees, right? You could round it to, looks like it has us rounded to 2 decimal places, so 59.32 degrees. That's what angle A would be. Let's do it for this next one. Cosine of A is 0.432, cosine of A. So the adjacent over the hypotenuse ratio is 0.432 on some triangle. So we're going to go ahead and undo cosine, and we would undo it with the arc cosine on both sides. And now we go ahead and we pull up our calculator, and we say if I punch in arc cosine of 0.432, it'll give me 64.40544,772 degrees. I'm going to round that to 2 decimal places, 64.41 degrees. So that's my angle A. And let's do one last one here. We've got the tangent of B. So the opposite over the adjacent ratio is 1.26 here. And we're going to undo the tangent with arctangent. So we undo it. And we've got this angle B would be the arctangent of 1.26. Again, make sure I'm in degrees and use that arctangent on your calculator. 51.56269851 degrees. We'll go ahead and round that to 2 decimal places. And that's a little introduction to trig ratios. Thanks so much for taking notes. See you next time.